In this video, I am going to be walking through some of the new general purpose features that were added to ObserVIEW 2024.1. There are more features than this, but this is the first introduction to the software and some of the major changes that were made, some of the new capabilities, and some changes to how things work in comparison to previous versions of the software. So the first thing I'm going to do is open a recording. You can drag and drop, you can do open recording, open existing projects, open from the MRU list. None of that has changed. One of the first big changes is adding graphs and what that looks like. In previous versions of ObserVIEW, we had an add graph menu that looked something like this. We have changed how graphs get added to more of a tree view that allows for filtering and better control of channels and a little bit better customization. So you can still use this add graph dropdown, which will create a specific graph, but you can also use the plus button, add a new page, click add graph, all of these different ways, and that will open up this traces menu. Or you can open the traces pane on the side of ObserVIEW. And this shows you all of the available traces that you have in the system. So here are all of my waveform traces. We have added statistics traces. This is new in ObserVIEW 2024. It's statistics time history graphs. We'll look at those in a little while. Custom scatter plots that you can use waveform data or statistics data to create. You can also use math channels. Your frequency graphs, audio analysis graphs, time frequency graphs, and then damage analysis and SRS graphs. So let's just start. I can do something as simple as create. I can hold shift. If I click on this, hold shift, I can multi-select. I can also filter this list by group. So if I wanted to change by trace type, something like that, this will become more useful when we update or when we add in what's called an analysis range. But I can also filter this list to only show Z. So now when I check these two, only my Z channels are visible. So a little bit more customization, some filtering, some cleaning up. Once you have a graph layout created, so in this traces pane, you can also continue to add graphs. So in this add remove traces menu, there's an add graph button that will create a new blank graph. If I click PSD, it will duplicate the channels that I had selected. So here I had microphone trace turned off. When I checked the all channels box, only the previous selected channels were included. I can now save this graph layout. So under graph, I can do save graph layout, save all tabs, save selected. If you save all graph tabs, you can give it a name, basic analysis, starting point, click save. And now in this load layout, at the very bottom, I have some options. So I've been creating a few different user layouts, user templates that I use for different applications. It's just an easy way to kind of jump to a basic starting point. So I have some shaker-driven modal, vibration criteria, VC curve analysis, and now the basic analysis plot that I just created. So easily save and load layouts. We've talked about the traces pane. There's also a trace statistics pane. So this can be customized. This is showing statistics either for the current graph range, so just the visible time window that I have here, or for the entire file. So you can select the range here, which traces are shown. either just the traces on this graph or all project traces, and then I can group them either by channel or by statistic. You can set all of those settings here. I can choose what statistics are going to be applied. So min, max, maxi, max, range, which would be peak to peak, mean, variance, standard deviation, RMS skewness, all of these standard statistics that everyone might want to see. So these are single point statistics for the entire window or the entire file. And then, like I said, we have also added time statistics, where I can create an RMS time history graph for this entire file. And so here's RMS time history of base X, base Y. I might want to add base Z. So there's my 3 channels. And I can customize this in the graph settings with both a time resolution, which is the distance between my points, and then the averaging time that is included in both of those. So if I want very short averaging time and time resolution, I can do that. It's just a great way to get a different overall view of your waveform data. So the next feature that we want to talk about is creating multiple analysis ranges. That's done in this tab on the left-hand side. So analysis ranges allows me to break up a file into multiple groups. And to provide a better example of that, what I'm going to do is actually append 3 different waveforms. So I have, in this case, this is from planar data, so a woodworking planar. And I had old blades, I had new blades that I put on, and then the third set is with a Helix cutter head. So I can append data, and on my desktop I have planar data. I can pick new blades. It's going to append that to the end, and we'll append one more of Helix, which is my last set. So here are 3 different environments, 3 different blade sets running through the same tool, the same type of wood being passed through. And I wanted to compare a few different things. One, the overall vibration generated, but also the noise. Helix had a claim that there was significantly lower noise, and while audibly being able to hear the difference, I wanted evidential proof. So now what I can do is create an analysis range for each of these. So I'm going to zoom out. My analysis range 1, we are going to make use some of these choices. And I can unlink my x-axis from the range, which then allows me to really zoom in and find that starting point and ending point of this particular range. I can then lock this range. So in the time domain, range 1 will always be this window of data. I'm going to call that old blades. I'm going to add a new analysis range. I can move that over, and I can now realign this. Zooming in, however you want to manipulate this. There's a few different ways. You can manipulate it down here as well. So we'll just cut that off so we don't have the dead space. And this is going to be new blades. Lock the time range. Add a third analysis range. Move this one over here. Move this over here. So what does this gain me? And then we're going to call this one Helix, which is a helical blade made by bird cutters. So there I have my 3 ranges. I can see them down here. If I click back, I can now make time data that's linked to those ranges. So if I wanted to add a waveform graph, and add another waveform graph. I can change this to be new blades and helix, so I could see the difference in the time domain between the three. I might also take this up a step. Maybe I want to create 3 tabs. And now for this one, I want to add a maxi max and a range. Let's just do maxi max for all of them. There we go. And I could duplicate this setting. Plus maxi max. Alright, so move this one over here, make this helix, make this new blades, and add my traces to this one. There. Oh, sorry, wrong drag and drop. There we go. There we go. So now I have all of my comparisons. I can look at these in, this would be maxi max peak level. The really interesting comparison of this set of data was actually in the octave graph. So I might move these over, create a new tab over here, and I can look at octave. And now you can see that I have the option to look at all of my traces. So I can regroup this, put analysis range last, and now easily add all 3 of my microphone traces on top of each other. In my graph properties, I can A-weight these to make it more appropriate for human hearing. This is 1/12 octave space, 20 to 20 kilohertz, relatively short integration time, A-weighted, and I can see the overall dBA difference between the 3. So the old blades at 105 dBA, the new blades at 99, and the microphone at 90. So this is pretty valid proof that there is a significant difference in these particular blade configurations. But I can easily overlay this data. I can compare all 3 analysis ranges, and this goes for any data set. So any spectral graph, octave graph, fatigue damage spectrum, shock response spectrum. All of those can be easily overlaid and compared. You can export that data, you can save that data. Great way to visually compare and visually understand what is happening. The other change, we added a few more parameters here. So if I create an FFT, and let's filter this by analysis range, we'll pick microphone. So here's my FFT data. We added this auto analysis lines, so I can check this box and say I want to default to 2 Hertz resolution or 1 Hertz resolution. The software will automatically pick the appropriate analysis lines configuration that gets you closest to that 1 Hertz resolution. If I switch this over to a different set of channels, if I switch this over to, let's just say Gearbox Z, I can do my AVD conversion. So I can look at this in terms of velocity. And we've added some new cursors. So if I open my cursor pane, in addition to the standard harmonic and some of the other statistics, we have a mean, a range, and a peak cursor as well. So here, if I insert a peak cursor, it will annotate the highest peak, but I now have the option, if I double click on this, to show me, say, the highest 3 peaks for each trace or of all traces. So the highest 3 of all of them or the highest 3 per trace. And yeah, makes it very easy to see this data, annotate this data, and then of course copy and paste it, export it, and somehow get it into whatever reporting mechanism or data that I'm trying to analyze and capture. The last quick tip, new change that I want to show is for transfer functions. In previous versions of software, it was a little bit difficult to have transfer functions with different reference traces. So now, if I create a transfer function, I can have it reference, let's say, base x, and I can then change this. So let's open the traces pane. So base x, and I want to see in relation to base x, gearbox x. And if I click add graph, it makes it very easy to now create a transfer function base y to gearbox y. So I can easily create appropriate transfer functions for multiple analysis ranges. So this is showing me for the Shelix time range, the transfer function between base y and gearbox y. For this range, this ratio. For this range, this ratio. So it's doing everything appropriately as you would expect it to show. Lots of other changes in the software. If you want to see that list in your About, there is a What's New in ObserVIEW. We have a few other videos that will be coming out talking about what can I do in ObserVIEW 2024. This is hopefully one of the first ones that you watch that talk about some of just the general changes and capabilities that have been added to the software, how they work, and how to navigate the software, at least as a starting point. If you have any questions, please reach out to support@vibrationresearch.com or vrsales@vibrationresearch.com. Thank you.